Hello, this is a continuation of the last video about algebraic operations where we learned about addition, subtraction, and multiplication. We're still gonna learn some about multiplication in this video, but also we'll learn about how to factorize. So what's factorizing? Is it a new term for you? Factorizing, in the most common or lay term I can imagine, is finding out a common term or a common factor, a common part in each term, and taking it out. So simply we're trying to find what's common in each term, and then we're going to separate it from the rest. Let's see. We're going to see some simple examples that you're probably already learning at some point. Let's say we have 4y minus 12. Is there anything common in each of these terms? You probably see that 4y is 4 times y, and 12 is 4 times 3. Now if you see it this way, you have 4 in both of these. So what do we do to factorize it? We'll take these 4 as a common factor, and then what we cannot take out, we'll leave in each term. So I'm just going to rewrite what I cannot take out. And this is a very common, simple example of what factorizing is. I'm just taking the common factor from each term. Let's see it in a more complex situation. If I have something like this, how do we factorize it? X squared is x times x. While this 12 here, 3 times 4 times x times y. What do we have as common factors here? You can see there are 3's in each of these terms. And then I have an x here and here. I also have... Oh wait, that's all I have. So what do I do with this? I'm gonna take the 3 out. I'm gonna take the x out. And what I cannot take out, I rewrite and leave it in each term. So this is how I factorize the second example. Going to the third one. Now we have a more interesting feature here. I'm going to introduce a new technique here. Let's say we have something like this. It's in the form of what you might know as ax squared plus bx plus c. If we have something like this, what we have to do is find out what two figures or two numbers that when multiplied gives you the a times c. So I want the multiplication result to be a times c, but I want the addition to be b. In this example, what do I have here? This is actually a 1, but we don't write it down. So I want the multiplication result to be 1 times 3, gives you 3. But I want the addition result to be 4. What two figures will satisfy these? In this case, I'm thinking of these two figures, plus 3 and plus 1. When they're multiplied, they give you 3, positive. When you sum them up, they give you 4, positive as well. So in template, this is the template that I'm using. After I find the figures here, I'm just going to put them here. And that's how I factorize question 3. This is going to come in very handy. Another example here. It's pretty similar to what we have in question 3, but it's a bit more tricky. So let's say I have 3x squared plus 8x plus 4. If I'm asked to factorize something like this, I still have to figure out those two things. What figures and when multiplied will give me plus 12 from 3 times 4. But if I sum them up, it should give me plus 8. The numbers I can think of are this and this, 6 and 2. If I multiply them, they give me 12, but if I sum them up, they give me 8. But in creating my template here, notice that there is one big difference from question 3. In question 3, my coefficient of x squared is 1, but here, the coefficient of my squared variable is 3. So what do? I make it like this. So that 3 is going to affect this, this, and this. Now that I've got this, I'm going to put in the number plus 6 and plus 2. Now that I have it like this, the 1 over 3 is going to be combined to either of these terms, the 3x plus 6 or 3x plus 2. In this case, I cannot divide 3x plus 2 with 3. So a neater approach for this is that I'm going to combine these two. What will I get? 3x plus 6 over 3 times 3x plus 2. 3 over 3 gives me x, and 6 over 3 gives me 2. And this becomes the final answer for factorizing this question. It's a little more intricate because now you have a slightly different template. You have to consider the coefficient of your squared variable. How do you find it? Easy enough? I'm hoping you're still following through well here. For next one, I want to introduce you to some other forms that might be handy for you. If you see this form, this can be factorized into this. For example, if I have 4x squared minus 9, this is actually this. And when I factorize this, what will happen? I'm following the a plus b times a minus b. So I'm getting 2x plus 3 times 2x minus 3. And that's how you factorize an a squared minus b squared form. I'm having the tendency to use this formula if I'm having two terms and I'm seeing some form of square there. If there is a form of square, I have enough ground to consider using this formula. Next one. If you have a plus b squared, this will not give you a squared plus b squared. Mind you that it will give you a squared plus 2ab plus b squared. So for example, if you have 2x plus 5 squared, it will give you 2x squared, with this being the a and this being the b, plus 2 times a, 2x, times b, 5, plus b squared. So you're gonna end up with something like this. Easy enough? If you have an a minus b squared, slightly different. Rather than having a plus 2ab, now you have a minus 2ab here. So that's the major difference. The other stuff remains the same. But please be mindful of this one. If this is negative, then that will be negative as well. Like if this is positive, this will be positive as well. So an example of this, let's say I'm having 3x minus 1 squared. This will serve as my a, and this will serve as my b. So I'm having a squared minus 2 times 3x times 1 plus b squared. So I'll end up with this. These three formulas will come in really handy, especially if you're having to make a square of something. It's gonna save you some minutes perhaps. So consider memorizing them and practicing with them. Alright, let's see some questions now. If we have this question, how would you do this? I do suggest pausing this video if it's helpful for you to try this first before you see how I do it. Then probably it will help you to understand it better because now you have to practice it. For this one, if we see, you have 15 can actually be expanded a bit. I can make it into 3 times 5. And now that I see it, I have 5 in both. Then I have a p here and a p here. I also have a q here and a q here. So all of them are going to go out as the common factor. What I cannot get out of each term, stay inside. So this will give me this result. Next question. What if you have to multiply something like this? We learned this in the previous video, but I just want to refresh it for this one so that you don't forget how to do it. Remember, it's going to follow a certain rule, like some call it the rainbow rule because it looks somewhat like a rainbow. Like you have to do it like this, followed by this, followed by this, and then finish with this one. There is no certain sequence that you have to follow, but you just need to make sure that each term from each bracket meet each other. So what do I have here? The blue one gives me 2x times x. And then I have the red one, 2x times negative 3. And then I have the green one, 3 times x. And the last one, the purple one, 3 times negative 3. So what do we have? 2x squared minus 6x plus 3x minus 9. And this gives me a final result of this. Now let's say you're given this kind of question and it says something like this, that this form is supposed to be 2x squared minus bx plus c. If you're asked to find what b is and what c is, can you do it? It's actually pretty simple. So what do we do here? The coefficient of x squared from what we have and what is given in the question, like this one, they need to match. In this case, this is already matching. This and this are already the same. What else do we see? Then this and this need to match each other too. So negative 3 is equal to negative b. It means b is equal to 3. And then if I'm seeing, say, this and this, what does it imply? It means negative 9 is equal to c. So c is negative 9. So if you're given this kind of approach, this kind of question, this is how you do it. I hope it's simple enough for you to follow. And next one. Let's say you have 7x squared minus 31x minus 20. How do we factorize this one? Remember, when we're having this kind of number in front of our x squared, in front of our squared variable, you need to make the template first. Our template for this will be 1 over 7, 7x, 7x. Then we start seeing what two figures that when multiplied gives you the a times c, or in this case, if you multiply it, it will be the multiplication result of 7 times negative 20. So it needs to be minus 140. But when you sum them up, you want it to be negative 31. So can you think of two figures that match this? I would probably go with, how about negative 35 and 4? Positive. If you multiply them, it will give you negative 140, but if you sum them up, it will give you negative 31. Looks fine for me. So I'm gonna put them in our template. Like this. Now that I have this, I think I'm gonna combine 1 over 7 with 7x minus 35. The reason is that they're divisible. So I'm gonna have 7x minus 35 over 7 times 7x plus 4. 7x over 7 gives me x. Negative 35 over 7 gives you negative 5. So I end up with this answer for question 3. How is it? Good enough? I hope you can still follow through well. The next one, let's see. If you're asked to factorize this, how would you do it? See, when I'm seeing something like this, there's a certain pattern that I'm seeing here. Like 9a squared. This is 3a that you squared. As for this one, this is 4b that you squared. Now I'm crossing my finger, I'm seeing the middle part here. I'm hoping that it somewhat have a 2ab similarity. If there is that pattern, then I'm using a certain formula, the one that we have previously. So in this case, this is 2 times 3a times 4b, is it? It is. In that case, do you remember our previous formula? Where this becomes your a, then this is 2ab, and this is your b. Following that pattern, I can use this to form this kind of formula. So what do I end up with? 3a plus 4b squared. And of course, it's a positive here because this is positive. If that one is negative 24ab, this will become 3a minus 4b squared. Moving on to the next question then. What if we have something like this? Well, this does look confusing. It has an x to the power of 4 rather than just squared. What do we do with this? Think about it this way. X to the power of 4 is x squared that you squared. And then 16 is 4 that you squared. If you see this pattern, this is like a squared minus b squared. So what can we do? We can use a plus b and a minus b. In that case, what do we have? X squared plus 4 and x squared minus 4. See? But this is not the end of it yet. If you notice this one, this is x that you squared. This is 2 that you squared. So you can further factorize this using the same formula with the a plus b, a minus b. You'll get x plus 2, x minus 2. So sometimes you have two steps like this. How do you find this? Easy enough? Now, next one is slightly more complicated. If we have something that looks like this, I admit it does look confusing, but hold on. Usually if you have multiple terms like this, I have a tendency to try grouping them, hoping that there is some similarity I can achieve. In this case, I'm going to try grouping this with this, and then this with this. For the blue one, I'm going to try taking the x squared out. What I cannot take out inside is x minus 1. As for the red one, I also want to try taking out the negative 9 out. If I take the negative 9 out, it will give me x minus 1. Now pay attention to the sign here. It becomes negative here because this combined with this will give you a plus here if you open up the bracket. So it is intentionally negative there. But now that you see this, can you see a pattern here? That this and this, they're the same. So what do? Let's take them out. I'm going to take the x minus 1 out. And what do I end up with? I still have x squared from the first term, and then minus 9 from the second term. Now this does seem a lot like question 5. This is x that u squared, and this is 3 that u squared. So what do we do with this? I'm going with the a plus b, a minus b formula again. So it will become something like this. How is it? Can you follow through well? I'm hoping that this is giving you a good foundation for what factorizing is, with some tips for how you deal with your common occurrences of factorizations. You'll see many square forms, but these formulas, these kind of types of question will help you a lot in approaching those questions. Okay? I'm hoping that this helps you in learning. Please do like, subscribe, and share with your friends who might need help with this kind of material too. Thank you for watching. Bless you.